This is a really fun problem, one that I really enjoy doing. And just because it has some interesting logic involved, and then it's got a little trick at the end that you got to be very careful of. The first thing to know is we're talking about two consecutive digits that must be divisible by 17 or 23. So it'd be helpful to know all those divisible. So I'm just going to write out the multiples of 17, which are 17, 34, 51, 61, 8, and 85, and then 23. And then this will be very nice for us as we go through and make out our list on this problem to be able to identify what to do next. Okay, so it starts by saying that the leftmost digit is 3, and then it says any two consecutive digits must be a part of one of these two lists, is really what it's saying. So the only one of these that begins with 3 is 34. The only one that begins with 4 is 46. And then you get to the first place where this problem gets interesting, and that is that you could do 68 or 69. So what we do is we branch off and make new lists, and we get 68 and 69. And so if you're looking at the 68, well, the next list would be 85, and then 51, and then 17. And then if you notice, if you put the 17 into there, the next digit is a 7, and there are no numbers that begin with a 7 in our list. So actually this branch didn't work. So then we look at the 3, 4, 6, the 9. The next one's a 2. And then we get to a 3, which means at this point we repeat. So this is a very nice problem because it actually repeats 3, 4, 6, 9, 2 every 5 digits. So it might be, if you want to find out what the 2000th digit is, if this is the first, second, third, fourth, fifth, you look for the one that's divisible by 5. So you might be tempted to say that the answer is 2. But if you were tempted to do that, then you would have made a mistake because the 1995th digit certainly is 2 because 1995 is divisible by 5. And so it's going to be the last one in our list of 5 digits that repeat. But the 1996 is 3, 97 is 4, 98 is 6. If we went this direction, it would be 99 is 9, and 2000 is 2. So that definitely 2 is a possibility. But it turns out that in this last little stretch, it's okay to go do the 8, 5 because we never get to the 7, which is our problem. And so 5 is a possibility as well. So our two possible ending points are 2 and 5, which have a sum of 7. So the key to this problem was the little trick at the end, which made you have to realize that the 5 was a possibility, and you had to look at the 1995th digit instead of the 2000s.